Good morning, friends. In this video, we are going to see the standpipe system, Nfpa and IBC code requirements like a flow, pressure, and sizes. And if a high-rise building like this have the standpipe system, then we will see how to size the tank and pumps. So let's start the video. As per Nfpa 14, we have three arrangements in the standpipe system. So first one is the class 1. So like you see here, we have the landing wall as a class 1. So in the class 1 system, the size of the class 1 standpipe is, the landing wall is 2.5 inches. So coming to class 2, we have the hose station. So the hose station, the size will be 1.5 inches. And coming to class 3, we have both the arrangement like landing wall as well as the fire hose cabinet, fire hose reel. So we have the 1.5 inch fire hose reel, fire hose station, and also 2.5 inch landing wall. So these three arrangement is there in the standpipe system. In this project, you can see we have the fire pump room, firefighting tanks and fire pump room is located here. And this is the standpipe 1. And in this standpipe, we have only the landing wall at each floor level. And the second standpipe is here. This is called as a combined standpipe system because here we have the landing wall and this is applying to sprinkler also from the same standpipe system. As per Nfpa 14, we can provide combined standpipe system combining combining both the standpipe, both landing wall and the sprinklers. But some civil differences says that we need to have the separate standpipe for the landing wall, fire hose cabinet, and separate riser for the sprinkler system. So you have to verify your local civil difference before you start the design. So in this case, we need to know what is the residual flow and residual pressure in the system to understand, to perform the hydraulic calculation and also to determine the pump size for the system. When you do the design, suppose for a high-rise building, if you have lots of system like landing wall, fire hose cabinet, and sprinkler system like I shown here, you have to perform the hydraulic calculation in different scenario, like scenario 1, scenario 2, and scenario 3. I will explain in this video all the scenarios step by step. And end of this video, you can easily understand and you can design whatever the system is given in your high-rise building project. So the scenario 1 or case 1, let's assume we have a high-rise building, the same high-rise building, but let's assume that we have only landing wall for the same project. And case 2, we have the landing wall plus fire hose cabinet without the sprinkler system. And case 3, we have landing wall, fire hose cabinet, and sprinkler. Mostly for the high-rise building, will come with this scenario, but I will explain all these scenarios so you will get clear understanding. So here we need to first verify what is the longest route or the remotest location. For example, here we have the pump and this is the nearest location for the standpipe, and this standpipe is located like a longest route. From here, this is the longest route. So in the longest standpipe, we have to verify what is the longest landing wall we have. So in the case 1, we are assuming that there is no sprinkler system, only landing wall we have. So in our case, this is the two remotest landing wall. So as per for the calculation, we have to assume two landing wall which is located in the longest location. And each landing wall we have to provide 250 GPM as per Nfpa 14. So here residual flow means the longest flow. We have to provide 250 GPM in the means for the landing wall. So let's go to the calculation now. So here if you see here, we have two landing wall. We need to assume even though you have 100 landing wall in different floors, for the calculation point of view, we have to consider only two landing wall. So first landing wall, we have to consider 250 GPM. And also second landing wall also we have to consider 250 GPM. So the total for this standpipe, even though you have lots of flows, we have to consider total 500 GPM for this standpipe system. So the first standpipe, I mean the residual standpipe or longest standpipe, it is clear. We have to assume 500 GPM. So now coming to the second case, we have additional standpipes. So for the additional standpipe, we have to verify how much flow we need to know. So you have one important condition. We have to verify the floor area, whether the floor area of each floor is less than 80,000 feet square or it is exceeding more than 80,000 feet square. So in our case, for example, consider the floor area of any floor. For example, this 80th floor, the 7th floor. For example, at this floor, we have the floor area of 70,000 feet square. And here we have 60,000 feet square. So there are different floor area we have. So our condition is whether the floor area is exceeding 80,000 feet square or less than 80,000 feet square. So for example, here the highest one 70,000 feet square. That means we have to assume only one standpipe That means the longest remotest standpipe for this standpipe system. So for this standpipe, as I told you, one landing wall we have to consider 250 GPM. So already here 500 GPM we consider for two landing wall, and the next one we need to consider 250 GPM for one landing wall. So the pump size for this project is 500 plus 250 is equal to 750 GPM. So this is the one arrangement. And second case, you need to know, for example, you have the floor area which is exceeding the 80,000 feet square. That is, as I mentioned here, if the floor area is exceeding 80,000 feet square, and this case you have to consider the second standpipe, the flow as 500 GPM, considering one landing wall, two landing wall. So if the area is exceeding 80,000 feet square and the floor area, the flow should be 500 GPM from here and 500 GPM from here. So in this case, the pump size is equal to 500 plus 500 is equal to 1000 GPM. If the floor area is exceeding 80,000 feet square, then you have to consider two landing wall in the next standpipe. Suppose in the high-rise building we have 3 or 4 standpipe. So that time, for example, consider we have the floor area for each floor is 50,000 feet square. So the area is less than 80,000 feet square. So let's assume that we have 4 standpipe. So that time we have what we have to do. We have to consider this landing wall, this last two landing wall. So 250 plus 250. 500 GPM. So 500 GPM will come from the last standpipe. Coming to the next standpipe, the area is 50,000 feet square for each floor. So we have to consider only one landing wall. So that means 250 GPM we need to consider for the pump. So 500 plus 250. Suppose consider we have third standpipe and we have fourth standpipe. And here also we need to consider one landing wall. So 250 GPM will come from here. And also last standpipe also we have to consider one landing wall. So total the flow of the fire pump will be 500 GPM plus 250, 750 plus 250, 1000 plus 250. The final flow will be 1250 GPM. That is the highest flow. Even though you have fifth standpipe, sixth standpipe, we don't need to consider all this one, because the 1250 is the maximum flow for the standpipe system if we have the landing wall. So similarly, if you have the floor area, for example, 90,000 feet square. So 90,000 feet square, then how to consider? So that time, the last standpipe, you have to consider two landing walls. So the flow will be 500 GPM. And coming to the next standpipe, you see you need to see the floor area. So here it is 90,000. That means it is exceeding the 80,000 feet square. So that time you have to consider two landing wall from here instead of one. So here also 500 GPM will come. So 500 plus 500. Suppose consider you have 3, 4, 5 standpipe. So here I told you maximum is 1250 GPM. Even though you have 10 standpipe, that is not an issue. Maximum is 1250 GPM only. So the third standpipe you have to consider only one landing wall. So it will be 250 GPM. You don't need to consider the fourth, fifth. You don't need to consider, even though you have 100 standpipe. I'm just telling for example, you don't need to consider. The maximum we need to consider 1250 GPM if you have only the standpipe system. So here 500 GPM plus 500 GPM plus 250. So total 1250, and we don't need to consider the additional standpipe. So the next case here is you have, suppose for example, you have landing wall plus fire hose cabinet. So both arrangement you have for the same high-rise building project. So this time what we need to do, I'll explain that. So here now we are assuming that we have the landing wall and fire hose cabinet. We don't need to consider sprinkler. That we consider the next scenario, case number 3. So what you have to do, first I will explain for the fire hose cabinet. You have to consider the remotest or longest fire hose cabinet 2 number only. So each fire hose cabinet you have to provide 50 GPM. So in our case, this is the longest standpipe. So here this is the longest, the remotest location of fire hose cabinet. So for this one I have to consider 50 GPM, and you have to see what is the next longest one. So next longest means this floor, this is the longest one, and the next floor you have to consider which one is the longest one. So here also you have to consider 50 GPM. So total you have to consider 100 GPM for fire hose cabinet. Even though you have 50, 100, 200 numbers fire hose cabinet, that is not an issue. You have to consider only 2 number longest or remotest fire hose cabinet, class 2 arrangement. So 50 GPM from here and 50 GPM from here. So total 100 GPM if you have fire hose cabinet, fire hose reel cabinet, class 2 arrangement. And if you have for example, you have 3 and 4 standpipe, and each standpipe you have the fire hose cabinet. For example, here also you have Firos cabinet class 2 type. Here also you have Firos cabinet like this. We don't need to consider the additional standpipe. So only this is the rule for the Firos cabinet. Only the remotest standpipe, only two class 2 arrangement you have to consider. So the flow will be 100 GPM. Now I told you in this case we have Firos cabinet as well as landing wall. So both arrangement we have. Now for the Firos cabinet the flow is 100 GPM. So similarly I have to verify for the class 2 landing wall also, or sorry, class 1 or class 3 landing wall. So here the first one Firos cabinet 100 GPM came. So now in this case we have landing wall plus Firos cabinet. So Firos cabinet is, this is the answer. Now I need to compare with the landing wall. So which one is higher? That one we need to select for the fire pump room. For example, landing wall, we have the same scenario like I explained in the case one. The first standpipe, I have to consider two number of landing wall, so each with 250 GPM, so it will be 500 GPM. Coming to the second standpipe, you have to verify the floor area is exceeding 80,000 feet square or less than 80,000 feet square. If it is less than 80,000 feet square, you have to consider only 250 GPM. I mean one landing wall in the next standpipe. If it is more than 80,000 feet square area, then you have to consider 500 GPM in the second standpipe. At third standpipe, you have to consider 250 GPM, and fourth standpipe 250 GPM till 1250 GPM you have to consider. So if you compare both the flow, here for the landing wall you are getting 1250 GPM, because of the Firos cabinet you are getting 100 GPM. So comparing with these two, 1250 GPM is higher. So the fire pump capacity will be 1250 GPM. So this is the arrangement we have for the class case 2 arrangement. And the third scenario here is we have landing wall, we have sprinklers, we have the Firos cabinet, like a combined system. So in the combined system, what you have to do, for example, here I have shown like two sprinklers. That means this line is extending like this, and this floor, and each floor we have the sprinkler system. So we need to consider what is the remotest or longest area sprinklers, and based on the Nfpa 13, we have to consider the like hydraulic area. So if you have not watched my previous video regarding the hydraulic calculation of sprinklers, please have a look at that, so you can clearly understand how to determine the flow and everything about the sprinkler system. So for example, consider we have the light hazard, and finally I got the sprinkler flow of 280 GPM. Just for example, I got 280 GPM from the sprinkler. So in our case, what is the scenario we have to do is we need to consider this arrangement like Firos cabinet plus sprinkler system. What is the flow is coming, and second action only the landing wall. We need to compare which flow is higher, whether this flow is higher or this flow is higher. Based on the higher flow, we have to size the fire pump. So in the third scenario, as I told you, sprinkler plus Firos cabinet we need to consider. For example, sprinkler flow is 280 GPM. So this is the remotest location. The pipe is coming like this, and which is going all the way down till the fire pump. So in this case, I need to add this Firos cabinet flow. That means I told you one Firos cabinet 50 GPM I need to add. So along with this 280 GPM, I need to add 50 GPM at this point, and when it comes down, you see, we have the Firos cabinet at this level also, and this at this point, I need to add again 50 GPM. So 280 GPM plus because of two Firos cabinet, I need to add 50 plus 50, 100 GPM. So total it will be 280 plus 380. It will be 380 GPM because of the Firos cabinet plus sprinkler system. So this is one action. And coming to the action 2, you have the landing wall. So this flow you must not add with this sprinkler and the Firos cabinet. That is completely separate, and this is completely separate. So if your project has landing wall, then you have to consider this flow separate and landing flow separate. Landing wall, as I told you earlier, we have to see the last remotest location. We have to consider two landing wall, and before that we have to consider one landing wall, and before that we have to consider like this. One by one, as I told you have to consider. But the important difference between only standpipe system and the sprinkler system is, if you have combined system like a sprinkler system plus landing wall, and the maximum flow for the landing wall and the system will be 1000 GPM. Because in the earlier stages, if you see my first case one, if you see here, so what I told you, the maximum flow will be 1250 GPM. Like first 500 GPM, two landing wall, and further each and every landing wall 250 we added like that till 1250. But if you have the combined system, I mean the sprinkler system plus landing wall, and the final flow will be 1000 GPM, not 1250 GPM. So in our case, what we have to do, we have to verify the sprinkler flow plus compare the sprinkler flow plus Firos cabinet, and you need to compare with the landing wall. So for the for the Firos cabinet plus sprinkler, we got total 380 GPM, and for the landing wall, how much we will get? Here 500 GPM and here 250 GPM. So in this project, the landing wall flow is very high, that is 750 GPM, compared with the 380 GPM of sprinkler plus fire hose cabinet. So we have to select the fire pump with the 750 GPM instead of this one. So these are the three scenarios we have when we go for the combined system or the high-rise building. So size is finalized and residual flow, now you understand. The third one is the residual pressure. So residual pressure in PSI for the class 1 system, we need to consider minimum 100 PSI, maximum 170 PSI. Residual pressure means, as I told you, this is a remotest location. I mean the longest location. So like you see here, this landing wall, for example. So the pressure available at this point, we have to make sure it is compliant to the NFA requirement, that is minimum 100 PSI, maximum 170 PSI. For the class 2 system, minimum 65 PSI, maximum 100 PSI. But the class 3 system is a combination of both landing wall plus fire hose cabinet. So of course, you know that the pressure at the landing wall is very high. So the minimum pressure will be 100 PSI, maximum is 175 PSI. So finally, for this high-rise building, as a summary, we have the combined system, landing wall, fire hose cabinet plus sprinkler. As I told you in the first action, we have to consider fire hose cabinet plus sprinkler. For the sprinkler remotest area, the flow comes like 280 GPM. Because of the two fire hose cabinet, I added 50 plus 50, it is 380 GPM. And the second action is the landing wall. The first, the remotest standpipe, I consider 250 plus 252 landing wall as a 500 GPM. And the next standpipe, we have to consider 250 GPM. So total, it is 750 GPM. Compared with these two, 750 GPM is higher, so we have to select the fire pump for 750 GPM. So the next important point is what type of building are required to have the standpipe system. So as per NFA 1, the first one is the 4 or more story in height. For example, here if you see here, 4 or more story means this is 1 story. So we need to verify from where at which level the fire hose engine can stand. So this is the level where the fire hose engine is standing. So you can see the floor level 1, 2, 3, 4. And here in this building, we have more than 4 story. So in this case, we need the standpipe system. 4 and more story, if we have the automatic sprinkler system. That time we need the standpipe system. 3 or more story, if you don't have the automatic sprinkler system. So if you don't have the sprinkler system in your project, that time if your story level is 1, 2, 3. So if it is more than 3 story, then you have to provide the standpipe system if your building doesn't have automatic sprinkler system. And the third arrangement is more than 50 feet above grade plan. So that means you have to verify the level from where the fire engine can stand. So this level to the height you have to verify. And if it is more than 50 feet, then we need to provide the standpipe system. So this is for the NFA. If you have the IBC requirement, then this height will be more than 30 feet. If your height from the fire engine standing level to the building height, if it is more than 30 feet, then you have to provide the standpipe system as per IBC or International Plumbing Code. But coming to NFA, this height requirement is 50 feet. And similarly, you have to verify the below grade plan. That means if you see in this image, the fire engine is standing at this level. So from here, if you have the basement, you have to verify the below grade level also. So as per NFA 14, first of all, you have to see, as per NFA 1, you have to see the condition here. If you have more than 1 story below grade, that means you have 2 basement. That is more than 1 basement. So that time you have to provide the standpipe system. Otherwise, if you have more than 20 feet or 6.1 meter below grade plane. For example, here, as per NFA 1, if you have this height, which is more than 6.1 meter, then you have to provide a standpipe system. If you go to the IBC International Building Code, this requirement is if you have more than 30 feet below grade plan, then you have to provide the standpipe system. IBC has some additional requirement as I showed here. If you have unsprinkler assembly occupancy, if you have the assembly occupancies, then you have to provide the standpipe system. Also, you have the open mall building, then again you have to provide the standpipe system in addition to this requirement. And finally, we will see how to size the tank if you have only the standpipe system. For example, the minimum supply for class 1 and class 3 should be at least 30 minutes. That means the fire water tank should have minimum 30 minutes of water duration, the holding capacity. If you have class 2 system, again it is 30 minutes. So this is the condition only for as per NFA 14 for the standpipe system, not for the sprinkler system. Sprinkler system, the concept is different. And I have posted a separate video for the fire pump room design. There I have explained the sprinkler system arrangement also. So in this case, this This high-rise building project, based on our earlier explanation, we got the total capacity for the fire pump is 750 GPM based on the landing wall, which has a higher capacity. So here, what we have to do, I have considered the fire pump with the 750 GPM and the water duration, as I showed you, it is 30 minutes for class 1, 2, 3. All the standpipe, we have the common water duration 30 minutes. So the tank capacity is equal to 750 GPM into 30 minutes is equal to 2250 gallons, which is equal to 85.17 meter cube. So let's say a round of value 86 meter cube. So normally for the firefighting and water supply, we are providing two tanks because in case if maintenance is required in one tank, the another tank can work. So that's the reason we always should have each tank with two compartments. So each tank with two compartments will come. So that means each tank, each compartments will have 43 meter cube sizes. So I hope you understand when the standard system is required as per Nfpa 1 and IBC International Blending Code. And also I explain the flow requirement, pressure requirement, sizing requirement for class 1, 2, 3 different standpipe system arrangements. And also we explain different scenario like case 1 landing wall, case 2 landing wall plus fire cabinet, case 3 is a combined system. And also we explain about the fire pump capacity and fire water tank capacity. So if you have any doubt, please add your comment in the comment section. Thank you. We will meet again with another interesting video.